Hey guys, this is Alan with Bothell STEM Coach, and today we're continuing with some AP Physics 1 problems, and this is a circular motion problem. I recommend that you pause the video, try to do the problem on your own, get as far as you can, and then continue watching the video afterwards and see how your answer compares. So a coin C of mass 0.005 kilograms is placed on a horizontal disc at a distance 0.14 meters from the center as shown above. The disc rotates at a constant rate in a counterclockwise direction seen from above. The coin does not slip, and the time it takes for the coin to make a complete revolution is 1.5 seconds. The figure below shows the disc and coin as viewed from above. Draw and label vectors on the figure below to show the instantaneous acceleration and linear velocity vectors for the coin when it is at the position below. Instantaneous acceleration is here, that's A, and his velocity is in this direction. That's circular motion because it's moving like this. The acceleration in circular motion is always directed towards the center, and the velocity goes tangent, and these two are perpendicular to each other. Determine the linear speed of the coin. Okay, well, to know the speed of the coin, I do know that it makes one revolution in 1.5 seconds. The question to get the velocity is I can use distance over time. How far did he travel in this 1.5 seconds? Well, he did one revolution. He did 2 pi, which is the circumference of a circle, 2 pi times r. R is the distance it is from the center, which is here, so that's 0.14 meters. Okay, and if I use a calculator, 2 pi times 0.14 divided by 1.5, I get 0.586 meters per second. Okay, that's how fast is he going, linear velocity. The rate of rotation of the disc is gradually increased. The coefficient of static friction between the coin and the disc is 0.50. Determine the linear speed of the coin when it just begins to slip. Okay, so if I look at a free body diagram of the coin, from the side, for example, I have gravity, normal force, and force of friction directed towards the center. Now, when the moment it begins to slip is when the friction is maximum, so that's mu Fn. So we know the force of friction is equal to mu times the normal force, which is equal to mg. Okay, why is the normal force equal to mg? Well, in the y direction, the net force has to equal 0. So that means F, and the only things in the y direction are the normal force and mg. So those have to be equal to each other. Otherwise, it would be accelerating vertically. So this is mu mg. This is the net force in the x direction, by the way, and that has to equal ma. What acceleration is it feeling? It's feeling centripetal acceleration. That's given by v squared over r. Okay, the m's cancel. And I want to solve for mu. Mu is equal to v squared over gr. Oh, no, actually, they want the speed because they already told us what mu is. So you actually want v squared is equal to r mu g. So v is equal to root r mu g. The radius is 0.14 meters. Mu is 0.5, and g is 9.8 meters per second squared. And this will be meters squared per second squared, and root of that will be meters per second. So 0.14 times 9.8 times 0.5, and the square root of that, I get v is equal to 0.828 meters per second. Okay. If the experiment in part C were repeated with the second identical coin glued to the top of the first coin, how would this affect the answer to part C, and explain your reasoning? It wouldn't, because our equation here doesn't depend on m. See that? So, like, if you put a second coin or it weighed twice as much, what would happen is the normal force would increase, right? This would then become 2 mg, but then this would also be 2m v squared over r. See, the mass is canceled. So no change, because the resulting relationship didn't depend on mass. Okay. So hope you guys found that helpful. I'll see you guys in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content. And see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.